So, hello everyone, and welcome back to my channel. Before we begin, I just want to mention one thing that I am currently suffering from a bit of cold and fever, so my voice may not sound very well clearly. So please manage it, and thank you for understanding. Now, let's start with an amazing problem based on the prefix sums, modular arithmetics, and subarray logic. So here, the problem is we are given an array of positive integers and we need to remove the smallest contiguous subarray so that the sum of the remaining elements becomes divisible by p. So if no need to remove anything, answer is 0. If possible, sorry, if impossible, answer is minus 1. So here the main idea is to let the total sum have remainder x, which is equal to total sum percent p. To fix the remaining array, we must remove an subarray whose sum also give x. So the whole task becomes find the smallest subarray with some percentage p is equal to x. We use here prefix sums plus hashmap to do this efficiently. So let's dive into the code. In line number 3, total is equal to sum is equal to nums, sum nums. Here, this calculate the total sum of the array. In line number 4, x is equal to total percent %p. This gives the extra remainder we must remove. Okay. In line number 6 and 7, like x is double is equal to 0 and return 0. Okay. Here, if the remainder is 0, okay, the sum is already divisible. So the answer is 0. Okay. In line number 9, prefix is equal to 0. Here, this will store prefix sum modulo p. Okay. In line number 10, sin is equal to 0, that is minus 1. Okay. Here we store prefix reminders and their indexes. We begin with 0 is equal to minus 1 to handle subarray starting from index 0. Okay. In line number 11, ans is equal to len nums, which is what we assume the maximum length of first. We will minimize this. Okay. Next code, that is for I num in enumerate nums. Here we iterate through each number with index. Like for update prefix is equal to prefix plus num percent p. Here we update the running prefix with like some modulo p. Okay. Now find required remainder we need is equal to prefix minus x percent p. This is the key formula. It calculates what prefix remainder we need before it to form a like a subarray whose sum remainder equal to 0, sorry, equals x. Okay. Like now like right now we have to check and update answer. So here is the condition that if need in scene, okay, ans is equal to what? Mean ans comma I minus scene need. If the needed prefix existed earlier, we found a valid subarray after the minimum length. Okay. Now we have to store current prefix. So here we write scene prefix is equal to I. Here we store or update the current prefix remainder index. So in the final return, we write that return ans if ans is less than len nums else minus 1. Here, if the answer is valid, return it, otherwise return minus 1. So here we have used two conditions.